For these problems, it's really important to keep in mind that the way that I do it may not necessarily be the way that you do it or someone else does it. Because there are so many different properties of exponents, you can choose whichever ones you really want. So for this particular problem, I'm going to choose to split this fraction up into two different fractions with the same base. So a fraction with my x terms and a fraction with my y terms. And then I'm going to use what I know about negative exponents, right? Negative exponents move that term from the numerator to the denominator or the denominator to the numerator. It just changes it to its reciprocal. So this will become 1 over x to the positive second power, x to the eighth power, times 1 over y to the positive eighth power, y to the positive seventh power, right? And we keep this 1 up here because everything always has a factor of 1. So there's like an invisible 1 here, an invisible 1 here. So when we move this down, right, the 1 stays, right? When we move this down, the 1 stays. So now I know that whenever I'm multiplying um, terms with exponents that have the same base, I add the bases. So this will become 1 over 2 plus 8 is 10, so x to the 10th power, times 1 over 8 plus 7 is 16, 15, y to the 15th power. So looking at my answer options, right? And then when we multiply fractions, we just multiply straight across numerator times numerator, denominator times denominator. So this will be x to the 10th, y to the 15th. And just keep in mind that because these are an x term and a y term, they're not like terms, so we can't combine them. So that will be our final answer. And that looks like that is this answer option right here. Okay, let's go to another problem. So for this one, I have only x terms, so I don't have any y terms. So I'm just going to use what I know about negative exponents to rewrite this problem. So I also have x squared in the numerator. The denominator also have x to the fourth, but this x to the negative 3 will move up to the numerator, right? We'll flip it and we'll make the exponent positive. So x to the positive 3 in our numerator now. And then same thing, in my numerator, I'm multiplying terms with exponents that have the same base. So I'm adding the exponents. And now I'm dividing terms with the same base, so I'd be subtracting. So 5 minus 4 is 1, and anything to the first power is just itself. So my final answer here would be x. So remember, when you're dividing, you subtract, right? When you're multiplying, you add. Let's do another one. So a lot of these will simplify down to something pretty nice. In the last problem, you will see it doesn't quite, but it almost does, right? A lot easier to look at than what you get originally. So here I'm going to go ahead and just use a couple of shortcuts. I'm going to move all of my negative exponents and turn them into their reciprocal with a positive exponent. So I'll have y to the fifth and x to the third in my numerator. In my denominator, I will have x to the third and y to the fourth, pretty sure. Then I'm going to split this up into two fractions again with common bases. So I'll do x to the third over x to the third times y to the fifth over y to the fourth. We know anything over itself is just 1, so that turns into a giant 1 here. And then we're just left with y to the fifth over y to the fourth, which we just saw when you divide terms with the same base and different exponents, you have to subtract. So 5 minus 4 is 1. So again, we just end up with y here. Let's do two more. So this one, I'm going to use what I know about negative exponents. Rewrite this. We just have x to the sixth because this term goes to our denominator. X to the fifth times x to the positive 1 in our denominator. I'm going to simplify my denominator first by adding our exponents since we're multiplying terms with the same base. So we will get x to the sixth over x to the sixth. which is just 1. So that would be our final answer. And the last one, and I know for a fact that this one doesn't simplify as nicely as the last three, because we have x and y terms and a couple of other reasons, but let me just go through it. So in our numerator, we will have x to the eighth, y squared. That is going to go to the top with a positive exponent. And this is going to go to the top with a positive exponent. So y to the third. And that's all over 1. But we do know that anything over 1 is just itself. So I can go ahead and rewrite this just as x to the eighth, y squared, x to the fifth, y cubed. And then I can rearrange this a little bit because multiplication is, I think it's a commutative, right? I think that's the word. Like 3 times 2 is the same thing as 2 times 3 is the same thing as 3 times 2. It kind of doesn't matter which order you write it in. Addition also. So I'm going to put all my like terms together. And then I'm just going to group them. So again, when I'm multiplying terms with the same base and different exponents, I'm adding the exponents. So I'm going to do x to the 8 plus 5, which is 8, 9, 10, 11, 12, 13. And then y to the 2 plus 3, which is y to the fifth. So again, looking at my answer options, it looks like that would be my final answer. Hope that helps.